So hopefully it'll work throughout the presentation.
Okay, all right, so good morning. My name is Charles Song. I'm a research scientist at Fraunhofer Center for Experimental Software Engineering. So this presentation, I'm going to talk about the work Fraunhofer has done at Weissense to perform automated GUI testing for the space network. And to solve some of the challenges of testing the space network, Fraunhofer developed a new approach using computer vision to perform a screenshot-based GUI testing on the space network. So before we get to the details of the new approach, why it's necessary, let's talk a little bit about the space network to understand the background. So the space network is a proprietary GUI running on a legacy OpenVMS environment. So this system has lots of screens, thousands of different screens to operate various operations of the space network, and is developed in Ada and Fortran. And the current testing practices performed at Weissense is they have very nice documentations of the testing steps and what to verify on the screen. But the actual testing process is still performed manually by the testers and the developers. Of course, this is very tedious work that should be automated because it's lots of work and it's very error prone. However, performing automated GUI testing for this kind of environment presents its challenges as well. So first, the OpenVMS, it's a legacy system. Therefore, it does not have robust GUI testing frameworks that's readily available. So we cannot perform the GUI testing directly, natively on the environment itself. Also, the space network itself uses several proprietary GUI libraries. For example, the Sher-Lubinsky library, that it's not easily portable to other platforms where the testing tools are available. And finally, the GUI library also depends on a legacy network protocol called the DECnet. So it makes it very difficult for to transport the space network window, GUI windows onto a different platform to perform the GUI testing. So here's some of the challenges. This is the reason why we need to create a different solution. So we actually came up with a platform solution to transport the GUI windows to a specialized Linux version via the X server technology. But in order to do that, we had to acquire DECnet components for this special Linux version. We needed the DECnet-enabled Linux kernel. We needed a set of DECnet tools that would run on Linux, and a custom compiled DECnet-enabled X server. So obviously, DECnet on Linux is not in high demand. There's only a very small user group on the internet that was providing support. And the latest version of Linux that we were able to find with the DECnet support is Fedora Core 6. And that's about 10 years ago when it was released. So it's no longer being supported by Fedora. So that leads us to the next step. We had to run this DECnet-enabled Linux version inside a virtual machine on the modern Windows platform. Finally, we have access to modern GUI testing tools for the space network. All right, so this is a overview of the platform solution. So you have the OpenVMS and the space network running on an alpha server, and the windows of the space network is being transported through DECnet, through the X server technology onto the Linux machine that's running inside a virtual machine that's running on the Windows machine where the testing tools are being run. All right, so we have the platform solution. So the next step is to look for the right tool for the job to perform the GUI testing. The most popular and the most robust GUI testing tools technology is reference-based testing. So for example, Selenium for the web application world is a reference-based testing tool. So in order to perform GUI interactions and do validation, it actually looks at the underlying HTML code. So for example, this login screen here, the login button actually has corresponding HTML code that describes what it is, it's a button, and what it looks like. It has the text login. However, for the space network screens, when it comes through the X server technology, all of the GUI information is lost. So for example, if we're looking through the user login through the X server, the login button is just pixels. So we cannot use reference-based testing tools for the space network. The next popular tools is the record and replay type. However, for most of the applications, the GUI is dynamic. Depending on how the user is interacting with the GUI, the items on the screen changes its location, and it changes depending on how the user is interacting. So it's recommended not to use record and replay tools if you want to build a robust testing framework. All right, so there is a potential solution, and that is a tool called Sickly. This is a screenshot-based GUI automation tool. So using this tool, users is able to search for image patterns on the screen to look for things and then be able to issue keyboard and mouse commands to the GUI itself. And it has some support for optical character recognition, or OCR. However, Sickly is not designed for testing. It's using some sort of automation script. It's a scripting language that it's expressed in user interactions in very low level, such as clicks, types, and finding images on the screen. So it's very difficult to create a robust testing framework using scripts versus using something like the object-oriented programming such as Java or C#. So to solve the problem, that's why we created the visual GUI testing approach and the tool support called PIGWIT. PIGWIT stands for Platform Independent GUI Testing. It is built on top of the Sickly's Java API. And using this technology, we're able to run this PIGWIT tool on all platforms, all modern platforms that supports Java. And it works with any GUI technologies. So not only does this approach work with the legacy GUI technology, such as the space network, it can also be very useful in mixed environments, such as if your system is composed of components built using various different GUI technologies, PIGWIT will be able to handle all of them. You only need one tool to support all of the different technologies. And finally, PIGWIT is designed to bring object-oriented programming kind of style into GUI testing. And we'll talk a little bit more about this in a little bit. So this visual GUI testing approach using PIGWIT, we took a three-step approach. So the first approach is for the users to define a model that describes the GUI under test. So this model will contain how the GUI will look and feel, how the users can interact with the GUI. And then using this model, we build a layer of abstraction at the much higher level, much higher than just the clicks and the finds. So the test cases can be built on top of this higher level abstraction. So how do we go from the GUI tool, PIGWIT tool, to the actual maintainable GUI test cases? So first, the user will use the PIGWIT GUI to build a GUI model. So this is a wizard or a guidance that will help the user to create things to look for on the screen to help them with the testing process. And then we generate from the GUI model into a set of custom APIs and combine it with the Pigwit core, which is a set of Java code that will be able to issue GUI interactions on behalf of the user. And finally, the tester will use the custom API and the Pigwit core to generate test cases that are more maintainable than using the scripting style. All right, so let's first talk about the GUI model generation. All right, so at the very basic level of the Pigwit technology is a concept we call predictors. So predictors are essentially images that can be used to identify elements on the GUI under test. So this is anything you can see on the screen. And using the predictors, users is able to verify things on the screen, is able to interact with the screen. All right, so this is still very low level, but Pigwit also allows you to have different states within a particular predictor. For example, the login button, when it has the focus or when it doesn't have the focus, it actually looks different on the screen. And because we're doing a visual GUI testing, this is actually very important. So we allow the users to define the different states of a predictor, so it's easy to identify no matter what state the predictor is currently in. All right, so now that we have the predictors, we're trying to build up into a higher level abstraction. So now we have the concept of components. Components are designed to give logical structure to the GUI under test. So using the predictors, we're able to build up the components. So for example, here we used 3 different predictors, the user login text, as well as the 2 corners on the bottom. So using these 3 predictors, we're able to find the location as well as the boundary of the login box. And using this approach, even if the screen resolution changes or the window size changes, where the login box might change its shape, those 3 predictors are less likely to change. So it will still find the right boundary and the right location on the screen. All right, so we need the predictors to build the components, but what if the predictors that we want to use to build a component is not unique on the screen? It's going to cause confusion. For example, if we want to separate the screen that's shown right now into 3 different components, one for Twitter, one for Google+, and one for Facebook, using the name as well as the binocular icon here, it's going to get confused because there are 3 of them. So we introduced the concept of anchors. So here, the user will be able to define an anchor predictor that is less likely to change, and then define a relative predictor, 1 or more relative predictors, that is closest to the anchor, but in a relative direction. So in this case, the closest to the southeast of the anchor itself. So now there's no confusion in defining a particular component. All right, so we have defined how to identify things and how to group things onto the screen. Now let's talk about how we interact with the screen using the Pigwit tool. So we have a set of actions. So these are GUI events that represent mouse clicks or keyboard inputs. So you can click on a particular location, click on a button, or and then type in a particular field. So we have a set of different actions. So for click actions, we support left click, right click, double click. And then also there are situations where you don't want to click on the predictor itself. We also support clicking a little bit off using an offset, to a certain location relative to the predictor itself. We also support drag and drop, or when we're testing mobile applications, this would be essentially a swipe in the touchscreen world. We also support type actions. So these are keyboard inputs where you can type things. Here we support parameters, so you can parameterize what you want to type. So this is important later when you want to create maintainable test cases. And it also supports special keys such as enter, as well as modifiers such as shift or control and alt and such. We also support things that are important to software testing, such as assert and wait. We want to see if on the screen a certain item has appeared, or wait for certain predictors to appear on the screen during your testing. So you can imagine you log in, you're looking for if the error message popped up or you went to the new page. All right, so actions are low level. So the next logical step is to group them together with something called action sequences. As its name suggests, it's a sequence of actions, but with a very special important difference. Something to note is that action sequences by design must be performed in the context of a component. So for example, if you have a sequence of actions to help you log in for the user, for example, I want to click on the email, type in the password, and then click on the login, it should only be relevant to the login component. It doesn't make any sense for you to apply it for other components on the screen. So this makes it easier if you want to change your actions later. For example, now you found a new, more efficient way of only using keyboards to log in. The test cases will be hidden from these kind of low-level details. All it's doing is calling the sequence login user. All right, so this is of course, there are more features on help you defining user interactions and defining screen elements. But we're going to move on to the next step of building the custom API that's used for the actual testing. So some of you might have noticed this Pigwit is really designed to match object-oriented design, to bring an object-oriented feel to GUI testing. So the components are very similar to classes in object-oriented programming, where the action sequence are very similar to public methods inside a class. So the transformation from the model to the GUI is very similar as well. So the components are included as Java classes. So the login components, once it's done building the model, you just create a login component, and you'll be able to issue action sequences, which are very similar to public methods. And notice here, the login user takes in parameters here. And this is where the parameters of the type actions will come into play. You can type in, it will ask the user for inputs. So now you can imagine using the same component, you can test for valid user login, invalid user login, and different user roles as well. So this is very good for software reuse, which is always good. All right, so this step is very simple from the user's perspective. All the compilation is done in the background by the tool itself. So once the generation of the custom API is done, you have a set of jar files that you can just include into any Java program for you to use. And the tester will use the jars to create the test cases. So here is an example of the test case written against high-level logic. So the test cases, as I mentioned, are shielded from the GUI changes. If the look and feel of the GUI changes, all you have to do is update the model, recompile the jar file, and the test cases won't have to change. And if the user interaction in the previous slide has changed, the user of the code will not have to change. So all you have to do is, in this particular JUnit test case, create a login component, issue the sequence user login, provide the email and the password, and then you're able to assert the whatever you want to test in your test case. So basically, unless the fundamental functionality of your software changes, the test case will remain the same. So unless you do not log in a user anymore in your application, or all of a sudden you require a third credential, you need it then your test case will change. Otherwise, the GUI changes or anything, the test cases will remain the same. All right, of course, Pigwit will get you part of the way into maintainable test cases. In order to use Pigwit correctly, just like you have to use a language correctly, you want to leverage good practices. So we recommend using the JUnit framework. For example, using the setup and teardown to set up your screen and clean up the screen between test cases. You want to use the JUnit test to create really independent and repeatable and self-contained test cases that will verify itself. And finally, using the JUnit asserts to actually tell you if the test cases pass or fail, so that you get a nice report. You leverage the JUnit platform in order to get your testing done. And of course, there are some other things you can set up really expensive setup and teardown codes, such as for Space Network, you can send a lot of vectors before you're studying your test case. Of course, you don't want to do that for every single test case that you run, so you can put those in the before class and after class inside the JUnit framework. All right, so that's the Pigwit tool that we developed and applied and deployed at the Whitesense for Space Network. So what's the current progress of the project? So first, we deployed a configurable initialization script for the Space Network framework equipment. So this is a very tedious step that is required for every single testing session. So this is a boot up all the machines that are controlling the satellite, pointing the satellite to the right location to be ready to receive data and such. And the interesting part about this step is that there's a lot of waiting, because when you move the antenna, it takes some time to actually point to the right direction. So there's a minimum wait time or maximum wait time of 5 minutes. So when we got there, the testers are basically issuing one command and then sit by the computer just waiting and then looking at the clock. And sometimes they get interrupted by other tasks and so on, and they forget. So 20 to 30 minutes, sometimes in the real world, can take even longer. So now they can just set up saying, I want to take up these set of equipments, and then run the script. After 30 minutes to come back, it's ready for the testing session. So next, we developed a extensible test suite for regression testing. So it will submit shows to the Space Network in order to perform any testing to see if any of the shows will cause issues. So we designed this test suite to actually be extensible using the Pigwit. So all they have to do to extend the test suite is by copying show files into a particular set of directories. And they can manage the test suite using the directory structure, so that is more natural for the testers. And the idea is for them to, right before you go home for the night, you just start the script and will run for 4 to 6 hours. And by the time you come back in the morning, the test result will be waiting for you. So the test can run unattended. All right, so this is still an ongoing project, so there's more progress to be made. Now I just want to share a few interesting lessons learned from this project using the visual GUI testing approach. So aside from the challenges we talked about earlier, Space Network also has another challenge for us, which is non-standard fonts that cause difficulties for the standard OCR technology. Of course, this is not the Space Network screen. So we actually found that it's easier to do image recognition rather than using OCR to read the clock, for example. And this is where the predictor states comes in. So we basically define a predictor that has 10 states, 0 through 9. And then we can detect what state using image recognition each digit is at. And then from there, we can compose the time. So this is actually more reliable than OCR, where it gets confused between 5 or, for example, letter E, because the pixels are very similar. All right. The space network GUI also does not scale to resolution changes, where Pigwit can handle slight changes in resolution. But either the GUI libraries or the space network system itself, when the resolution changes, it actually redraws the component so that the aspect ratio is completely different. So to keep things simple, it's easier just to maximize a space network window on the test machine. So we have a dedicated test machine so that it simplifies the testing process. All right, so next is image string search. So if you're looking for text using image, always remember this is a substring search. So if we're looking for a directory called Fraunhofer, it's actually going to return 3 different results because it's always a sub search. So in order to avoid these kind of confusions, it's better to add a little bit of white space in your predictor so that it won't be confused with the Fraunhofer _2 or _test. And finally, something to keep in mind as you do the automation testing is that automated tests do not have to be perfect to be very useful. This is very similar to the 20%, 80% rule. So you want to simplify assumptions. So I'll give you an example. So there are screens that are very complicated in the space network where you see lots of telemetry data coming in. And the testers, for humans, it's easier to look through this column and verify the data rate to see if they're good. But it's a little bit more difficult to do so automatically. But it's very easy to see using the Pigwit tool to see if the link is in the current state. Is it green? Is your data coming in at all? And then that 90% of the time, that's enough for a particular test case. So of course, later on, you can make the test cases more complicated to be more accurate. But this is enough to get 80% of the way. And also, humans are very good at taking shortcuts. So for the different equipments, there's a prime, and then there's a backup. And the humans will looking, oh, this one is already toward the prime. Let me make the other one the sub. But for automated script, it's a little bit harder. Then you have to detect which one is a prime and so on. So for the script, just simplify the assumption. Let me take down all the equipment and then set up so that the first machine is always a prime and so on, so that you have this very stable testing environment where you don't have any surprises. All right, so as I mentioned, this is an ongoing project at WiseSense, and the Pigwit tool is being constantly improved, and we applied it to various different projects as well. We have used it for mobile testing, which improved to be very useful, as well as some environments where there are multiple GUIs that had to interact, and Pigwit created a very smooth interaction between the different GUIs. But of course, it can be improved. So the first thing we want to hit is to streamline the API generation or the jar imports. This is the second step in the 3-step process. It's still necessary, but we think we can make it so that from the user's perspective, there are only 2 steps to Pigwit: generating the model and writing test cases. Also, we want to improve the existing logging. So since we're testing a system using a GUI approach, we might as well generate reports and logging that's visual as well. Right now, there's a limited support for visual logging, where when something goes wrong within your test case, we actually take a screenshot of the time of the failure so that the testers can come back later to see what actually went wrong. So it captures the screen state. But we can go a little bit further by basically documenting the entire testing process. So the humans can just come back and read through the screen to see step by step how to do the testing process and how it went. And there's even ideas about using Pigwit as a training tool because you can see it run, the mouse and what it's selecting and so on. It's a very useful way to train new operators for the space network as well. Finally, we need to create a better OCR solution for the space network environment, some sort of custom OCR solution to apply difficult fonts. So this will open up make the GUI testing even easier for the testers. And finally, we're in the process of transferring knowledge of the Pigwit technology to the NASA testers and developers. Of course, once you get the tool into the hands of the developers and testers, they start getting ideas of new use cases for the tools and the technologies and so on. All right, so if you have any questions, I'll take your questions now. Here's my contact information if you want to talk to me offline.
I guess just quickly, I'm glad you chose that particular example. We actually had a discussion in this room the other night where you might be in a situation where you're working with scientists and engineers that are not familiar with the software and not familiar with perhaps coding.
Right.
In my particular field, where I do work with a lot of scientists and engineers, we do give them an example. We've had quite a few of them, and actually I am one of them that has crossed into the validation sphere, but coming out of a scientific role where we might not see what's going on behind the scenes. So we show them the login. We ask them to test it not just with a wrong password, but with a blank password as well.
Right.
And that's just a very basic, simple example that drives it home, though, to the scientists that don't have the GUI to, and everything going behind the scene to be able to identify that. And I like that you brought up with the assumptions. A lot of times, you can even tie this to a project management standpoint. I've seen a lot of problems in what was assumed. Mm-hmm. And then sometimes you end up somebody makes an assumption, say at step B, and at step E you see the problem. And you go back and it ends up being something, and had you caught it at, say, B or C. So if you simplify and you're clear, I think that's very good.
Right.
So, and I enjoyed your presentation. Thank you.
Thank you.
We don't have any questions online. Do we have any more in the room? Come on up to the next.
Somebody has to ask it. I mean, that was like a list of legacy technologies. It would have been hard to come up with one more to list there, right? It's on an alpha. It's running DECnet. It's running OpenVMS. I hate to say ADAS, but ADA, Fortran. Are there any plans to actually replace this, and will the GUI help?
Yeah, the next generation of space network is in the plan.
So this tool will be replaced, and then the GUI tester will be used to test the new one?
Well, there's no concrete plan, but the technology can be used since it doesn't care what technology is used. I believe the new technology is Java, but it's using different tools. There's web-based, and then there's a Java GUI, so Pigwit will be able to move seamlessly between the technologies as well.
Okay, we're going to go ahead on to the next presentation, and after this presentation,